Hello everybody, my name is Amy Baleni, and in today's presentation I would like to present to you the report or the project of the upgrade of Mangaung M10 road from kilometer 0 to kilometer 3.35. The UNISA Department of Civil Engineering Road and Transport Division has been appointed by the Mangaung Metropolitan Municipality for the consulting works and is to compile a design report of the M10 road kilometer 4 to kilometer 7.35 and is therefore required to upgrade the existing single-lane two-way road to a dual carriageway, which means from 2 lanes to 4 lanes in Mangaung Bloemfontein. The design requires a geometric pavement and a drainage system design. So in this slide, this is the area of the project, and that is the road that we will be upgrading. This project is in the Free State province and it forms part of the Mangaung Metro Municipality in the Motewa District Municipality. The highlighted area represents the 3.35 kilometer proposed road, as I said, section located within the heart of Mangaung Metro in Bloemfontein. The pre-existing pavement deteriorated over the years due to traffic loading, insufficient drainage, and low periodic road maintenance. So the Mangaung's economy is the largest contributor to the GDP of the Free State province, and in 2022 census did a study of the Mangaung, of the Free State, of Bloemfontein, and the population is actually around 811,000, which is actually the biggest population within this area, as Mangaung is the capital city of the Free State. The proposed road is one of the main roads used to travel from the informal settlement, where a high population of Mangaung resides into the city, where most schools, workplaces, shops, and a lot of places are located. Malls. Thus, the road has high volumes of uncontrolled pedestrian and vehicular traffic. This road leads into the National Road N8, which leads right into the heart of Mangaung CBD. The main objective of this project is to design a road that will be able to handle traffic efficiently, to provide safety, and to focus on the environmental and economic needs of the community. The visible cracks, the potholes, and the surface failures is a clear indication that this road section has indeed exceeded its maximum lifespan and is due for an upgrade. So the terrain has a flat topography with an elevation of 1,395 meters above sea level. The existing soil conditions found in this area are loam, sandy clay soils, and sandy clay soils. The soil ranges from sandy fill in the upper layer to a silty and clayey sand for the deeper in situ soils. Bloemfontein is considered to be a dry, moderate region with the highest precipitation occurring predominantly during the warm summer seasons between December and January, with the maximum rainfall of about 85 millimeters. And the climate of this region is generally to be considered semi-arid. The area is relatively water scarce as Mangaung is increasingly experiencing bulk water shortages. So for the traffic data of this project location, the current annual daily traffic per day was given as 2,301 with the last traffic count done in 2022. Automatic traffic count surveys were undertaken over a 2-week period by the Department of Police, Roads and Transport, Free State. The flow patterns are generally similar to the various days. In the AM peak hour, which is between 7 in the morning and 8, traffic volumes range between 190 and 260, and the average hourly flow is approximately 230 vehicles. In the PM peak hour, which is around 5, more or less. Well, yeah, when most people come back from work. The same maximum AM is actually the same as the maximum AM peak period. The design guidelines used for this project was the TRH26, which is the Geometric Design Manual, the Sunroll Geometric Design Manual, the TRH17 Geometric Design for Rural Roads, the TRH4 Structural Design of Flexible Pavements for Interurban and Rural Roads, the South African Pavement Engineering Manual, Chapter 4, the Guidelines for Human Settlement Planning and Design, Chapter 6, and the Sunroll Drainage Manual. And all these design guidelines include the pavement design, the drainage design, and the geometric design as well. So for the cross-section design of this road, the length was 3.35, which is kilometer 4 to kilometer 7. The lane width is 3.4 for all 4 lanes. 3.4 meters for all 4 lanes. The sidewalk is 1 meter, which is paved, and the design speed is 80 kilometers per hour. And the camber of this road was designed to be 2% on both sides of the road. So the software aided design that was used for this project was the Civil 3D design. And in the next slide, I will be walking you through the steps that I used for the geometric design within the Civil 3D software. So step number 1, what I did was to import the road survey points or the data into Civil 3D. And then I created a surface, which step number 3, I added the point group by adding the contours to the surface. And number 4, I created the alignment by clicking on the alignment creation tools. Number 5, I chose the tangent to tangent option, which is around here, with curves to draw the road alignment, and then I created a surface profile. But I also had to create another surface profile that will modify the ground and the cut and fill of the existing road. And then after that, I created the assembly, which by creating this assembly, I'll be creating the road section because it has the road section elements on it. And then thereafter, I created a corridor, which is a 3D model representation of the road designed. And then after that, I decided to take a tour by driving on the road to see it in 3D full form, or how it looks. And that's why you see that this is the road and these are the lanes, and that is the, the curbs and the sidewalks. So after that, I did target mapping to target the design surface. After that, I went through by creating sample lines for the cut and fill volumes and the sections, and then I created multiple section views. And here, as you can see, these are the sections at, well, 40-meter intervals, as that was the requirement in the report. And then after that, I created a horizontal curve data table. Well, then I created a bulk earthworks material list using quantity takeoff criteria. And then I compute the material comparing design data and surface and the existing design surface. After that, I created the mass hole diagram, and that is my mass hole diagram. And then for the last step, I created the sheet sets, but which is by creating view frames, and that is for me to be able to have, well, the drawings of my design. So now I will walk you through the pavement design. This area in the Mangaung was found to be in a dry region. Well, it's mostly is between dry and moderate, so let's just take it as a moderate dry region. The category was category class B, and the pavement class was category B, and the pavement class was ES1. The structural design period for this road was 15 years. So as we can see, the first option is the granular basis, and here is road category B as ES1, and this is my pavement design, and that is my foundation. Pavement option 2 was cemented base, and then this is my proposed design, and that's the foundation. And then for option number 3 was the water-bound macadam bases, and yes, that's the pavement and that is the foundation. So this is, well, clear view of the pavement structures. So what was used, or what the option that I picked was option 1, and within option, which was the granular basis or the granular base. So within option 1, there were also 2 options. I had 2 options to choose from, so which I can choose either one of them. The option 1 was this one, and this one option 2, but the foundation of both options were the same. For the road surface drainage requirements, the road in itself is used as one of the drainage elements, which is designed with a crown or a 2% crown to assist with removing the water from the road surface and directing it to the curbs and thereafter into curb inlets. The road is designed with curbs on either side of the road to remove runoff or the water from the road surface, preventing it from flowing into the yards of the nearby residents. Drainage of the road reserve involves removing water from the road surface into the longitudinal drain and its further removal to areas where it can safely be discharged downstream of the reserve. In most cases, the road reserve and the roadway use the same drains to remove water from the surface. So the design goal was to give the neighborhood a sustainable vehicle and pedestrian facility for the community resident or residents where the road is located. The upgrade will resolve all the construction constraints and will definitely increase efficiency of the road users who commute between the central or the CDP and this project area, which is a residential area. So widening the road will improve the traffic flow and it will definitely reduce the accidents. So